All right, so this morning is going to be kind of our last bit of time really focused on all types of graphing. We will have another graphing activity this week when I can get the Chromebooks again. But that'll be today and that day will be kind of it for graphing just by itself. Graphing's still part of other things that we do. But today will be our last day kind of focused on looking at both position versus time and velocity versus time graphs, being able to make calculations from both, okay, that are like the calculations you might encounter on, let's say, a unit exam, right? I'm also going to try and look at when that unit exam is going to be and give you some idea of that today as well, so around a date anyway. So we have to remember a couple of things here, guys. First off, we can calculate displacement by going final position minus initial position. So if this is a position versus time graph and it wants to know, let's say, the displacement from time 0 to time 5 seconds, I would take this position and subtract this position, and I would have my displacement. Everybody follow? Okay. If I want to find the distance traveled for all of those, then I have to find the distance traveled in the first section here, the distance traveled in this section, which would be 0 because I think that was supposed to be flat. Okay, and then the distance traveled here, and do what with them all? Add them all together. Okay, I'm going to use v equals d over t. Speed is distance over time, and velocity is displacement over time. Use those two formulas on a position versus time graph as well. Okay, remembering that sometimes that means for this formula that it'll be pf minus pi over t, or the slope of the line if it's just a single linear graph. Okay, so that's what this is saying down here. For a velocity versus time graph, okay, we need to remember a few things about those. All right, so if we have this velocity versus time graph, okay, the things that we can read directly off of it are obviously velocity and time. Okay, if I want to calculate acceleration, how would I do that? Right, VF minus VI over T. So if it asked me what's the acceleration between here and here, okay, I would take VF, okay, this would be VI, and then whatever the time was, okay, that's what I would divide by. Or if it's just a single linear line, I would calculate it. If the graph looked like this, the acceleration would be the slope. Okay, because it would be the change in velocity, which is the y-axis, divided by the change in time, which is the x-axis. All right, if it asks you to calculate displacement, that's when you got to do all those shapes. Okay, remember that finding those shapes is really just doing this calculation. D equals average velocity times time. Even when it's a triangle, that's really all you're doing, okay, because you're using the halfway point, okay, between the initial velocity and final velocity that actually is the average, and then you're multiplying it by the time, okay, and getting the displacement for each section and then adding them together. Okay, ringing a bell. Okay, so this is the last day that we'll have for kind of practicing this stuff. The thing you're working on today, I used to give out as an assignment that came in for marks, okay, but we're just going to do it as a worksheet in class. So it says assignment on it, I think, but don't worry about that. Okay, we're just going to do it for practice in class today. Okay, questions on what we're doing? All right, so the worksheet booklet, okay, has the picture of the graph, which I'll leave up here. Okay, so that's the graph, and then the questions are under it. Okay, so you'll have to kind of go back and forth, or like I say, I'll leave the graph up here. I'll make it a little bit bigger. Right, so maybe you guys can read the graph this way and have the questions up on your phone, okay, so you can check them. All right, if there's questions, please ask so we can go through them. I want to make sure everyone understands what we're doing with graphs before we move on, okay, to something else. Okay, so for the velocity versus time graph, if I want to find the total displacement, what am I looking for? Right, I got to find all the shapes, because for each section of the graph, I have to calculate how far it goes by using average velocity times time. So I've got to figure out some of the shapes. So I'm just going to go up to about time 10 seconds, and then I'm going to leave the rest to you. Okay, so I want the area between the line and the x-axis. That includes the negative part here. Okay, these triangles will just have negative areas, and that's fine. This is where the object's going backwards, and it's retracing its steps anyway. Okay, so for this first part here, the line's not at 0, so there's actually like a rectangle that I could draw pretty much all the way across. Okay, whoops, to 10 seconds if I wanted to. Okay, I would say I would probably stop at 10 seconds because that would give me, maybe an easier time making this triangle here for after 10 seconds. Then I would have a triangle there. I have this big rectangle and that triangle, right? Didn't take long to separate that into triangles and rectangles. Now all I have to do is go average velocity times time for each shape. So for this rectangle here, the average velocity during this long rectangle here is 3 meters per second, right? Because that's where 3 is. And it's 10 seconds long. So 30 meters during that rectangle, 3 times 10. Okay, for this triangle here, okay, the height of it goes from 3 to 12. Okay, so the height of it is 9, and it is 3 seconds long. So 9 times 3 is 27, but it's a triangle. So divide it by 2, and we got 13.5 meters. You guys following what I'm doing here? Okay, the average velocity during this triangle here, okay, is the height divided by 2. Well, the height is 9, divided by 2 is 4.5. Okay, off we go. Everybody with me? Okay, that's all we're doing here is calculating the area of these shapes by using the average velocity times the time. So for this rectangle, okay, the average velocity during this rectangle is the height of this rectangle. Now, not all the way to the bottom, okay, just the height of this rectangle. It goes from 3 to 12, so the height of it is 9, okay, and it goes for 7 seconds. So 9 times 7, okay, we're looking at 63, right? Okay, meters, and then do the triangle again, height, base times height over 2, and you're golden. Okay, all we're doing here is finding the area of each shape. Then at the end, I add them up, including these ones that are negative. Right, so that'll take some displacement off because it'll have been retracing its steps. All right, other things that you're being asked to do on this graph, average velocity over the whole trip. Okay, well, how do I usually calculate average velocity? Total displacement over total time. So I can use the number I calculate in part A and just divide it by the total time for the trip. Okay. So the questions are not like overly difficult. The first one takes a long time because you got to calculate all the shapes. That sucks. Okay, but after that, okay, you can use a lot of those same numbers over again in your other calculations. Okay, I'll give you a few more minutes to see if you can finish that one up, and then we'll have a look at it. And if we want to know the distance traveled between 0 and 10 seconds, it's the same as the displacement because it's only going forward. Okay, so all I have to do is find the areas of these shapes, add them together, and the distance and the displacement are the same. The only difference is one's positive and the other has no direction at all. Okay, it would have been a tougher question had I asked it between 0 and 20 seconds, because then I would have had to, instead of making these negative, make them also positive and just add them up. Yep. Okay. How many people are done all the way to G on that one? Okay, I'll give you a few more minutes. There's some more after that, obviously, so you can work on those. Okay, but I'm going to go over probably F and G here in a little bit. Okay, so let's quickly look at F and G here. Okay, so we've got average speed between 10 and 20 seconds. If I want to find average speed is the distance divided by the time. Right? Well, the time then, okay, is 10 seconds because it's between 10 and 20 seconds. So that part we already have. Okay. Then we need to know the distance traveled between 10 and 20 seconds. All right. So if I'm only going to 20 seconds here, then I'm going to have to alter this number slightly because I'm only going to go to here, which will give me this rectangle and then that triangle. Okay. So I'm going to alter that so it's -2 times 5, which is 10. So this is -10 meters, and then this one is 10 by 5, so this is 25. Okay, everybody all right with those numbers? All right, so now what I want to do is calculate the total distance traveled. So I'm just going to add these numbers together, whether they're negative or positive, doesn't matter because I'm calculating a scalar quantity. So 45.5 plus 9 plus 35. Okay, so my total distance is 89.5 meters, and that takes 10 seconds. So 8.95 meters per second during between 10 and 20 seconds. All right, everyone follow how I did that? Okay. Now, obviously on a test, I probably wouldn't give you one that would involve that many shapes because that just tells me how fast you can do it, not how well you can do it. So it would probably be something with fewer shapes. Okay. For part G, it wants to know the acceleration between 13.5 and 22 seconds. All right, so acceleration is VF minus VI over T. All right, so between 13.5 and 22 seconds is going to be, what, 8.5 seconds? That's right, 8.5. Okay. Okay, and then, so 13.5 seconds is right here. So our speed there is 0. Okay, and 22 seconds, it's also at 0. So our acceleration during that time is 0. That was pretty easy. It looks like it should be tougher than that because there's something going on there, but because its initial velocity and final velocity are both 0, technically, even though it did do something, it didn't accelerate during that time interval. Okay, everyone kind of follow me on that? It's a weird one, okay, but it can happen. Okay, any of these other ones giving us trouble? Okay. Is that the only one I had for that? That's just question 8. Okay. All right, so how are we feeling about the different graphs? Like if I give you a quiz tomorrow, which I'm going to do, spoiler alert, okay, give you a quiz tomorrow that's going to have a position versus time graph and a velocity versus time graph on it, and ask you to do something similar to this with a smaller graph. You guys will be able to handle it. Okay, so tomorrow also, okay, we're going to be doing our velocity versus time graph lab. Okay, so we did a position versus time graph lab already. That's due tomorrow, incidentally. Make sure you have it done. And we're going to do our velocity versus time graph lab tomorrow. Now, we don't actually have a lab procedure to do. I'm just giving you the data for this one. Okay, what you'll have to do is build the velocity versus time graphs and then perform some simple calculations with those. Okay, they're not like this one. They're just going to be single line graphs of various cars accelerating. Okay, so it won't be anything terribly complex to analyze, but you're still going to have to do things like calculate the displacement, so calculate the area under the line, calculate the acceleration using the slope, all of that kind of stuff. So that's still going to be there. That's what we'll be working on tomorrow. Realistically, that's a lab you should probably get done in class because there isn't actually a procedure. You just have to build the graph and answer the questions. I mean, you still have a hypothesis and stuff like that, okay? But it shouldn't take you as long because we won't have time spent doing the lab, acquiring the data. We already have the data, okay? So hopefully that one won't be a ton of homework for you. Okay, also guys, remind your parents, okay, that I would be more than happy to talk to them at parent-teacher interviews. I know a few of you have already got booked in. Make sure you come along. Make sure they get booked in if they want to, okay, because I still got spots available as of this morning.